Hello everyone. In today's lecture session, let us discuss about the instruction set of 8086. So in previous videos, we have discussed about the architecture of 8086. Here, we are going to discuss about the instruction set. There are different types of instruction sets in 8086. One is data copy or transfer instruction. Then arithmetic and logical instructions, branch instructions, loop instructions, machine control instructions, flag manipulation instructions, and shift rotate instructions and string instructions are also available. So 8086 has a lot of instructions. All those instructions are categorized under any of these. These are known as the instruction set architectures of 8086. Let us discuss the instructions one by one under each category. First, let us see the instructions under data copy or transfer. So, we know that from the architecture, 8086 has segmented memory. That is, it has different segments, segment registers. It has pointer registers, it has index registers, as well as it has flag registers. So 8086 is a processor, and so it do not have an inbuilt memory, and the transfer of data will be taking place between these registers or if or from a memory. So when based on the operands, based on how we represent an operand in an instruction, we have different addressing modes. That too we have discussed in previous lectures. So here the different instructions we are going to look into. So in order to transfer data from one register to another or from one location to another, we need some transfer or copy or move instructions. So first among that, and the most simplest one, is the move instruction, that is MOV. So this instruction copies a word or a byte of data from some source to a destination. So here different syntaxes of these instructions are given. This is the instruction and these are the operands. If you see, when we speak about move instruction, we need a source as well as a destination. Here in 8086, this will be the source and AX will be here. This location will be the destination. And see, this AX as well as BX both are general purpose registers. So this instruction says that from the general purpose register BX, the data has to be moved to the general purpose register AX. And coming to the next syntax, see 5000. If it was written as 5000 directly without any square brackets, then it means that it is an immediate data. So this immediate data 5000 has to be transferred to AX. So once after execution of this instruction, the data in AX register will be updated to 5000. And this H here denotes simply it's a hexadecimal value. That's it. Similarly, this is source index register. The contents of the source index registers can also be, since it is in the square bracket, it means it is indirect addressing. So the contents in SI register, the source index register, will be moved to register AX. So similarly, we can have different syntaxes for move instruction. Now coming to other instruction, a commonly used instruction is push and pop instruction. These two instructions are related with the stack register. Whenever we need to transfer a content from a stack from a register to a stack, or from a stack to the register. That is, when we see the normal working of a microprocessor or the flow of functionalities, the main program will be executed, and whenever it come across a procedure or a subprogram or a subroutine, it has to switch over the task from the main program to the subprogram. So at that time, the next address of the instruction in the main program will be kept on the stack, and then it will come to the subprogram. After execution of the subprogram, once if it sees a return instruction in the subprogram, it will return back to the stack, will pop the address of the next instruction to be executed from the main program, and then will return to the main program. So push instruction is used to push the register address into the stack, and pop is used to take the address from the stack and to retain the processes. So for this we need push and pop instructions. So push and pop instruction has these syntaxes. Then we have exchange instructions also. When you see the move instruction, suppose if it is move bx comma ax, for example, let us take this one, move ax comma bx. So in this case, if you see, the contents of ax will be moved to bx, and so the content in the bx will be deleted, that is overwritten by ax. So that what has happened in bx, so we cannot retain what is there in bx. In any cases, if we need to retain the content what is there in the bx register destination also, then we can go for an exchange of instruction, exchange of byte or a word. So exchange instruction means ax will be moved to bx and bx will be moved to ax. So that is the difference between move. If it is move, if we use move here, the data in bx will not be retained, will be overwritten by ax. Ax will have some random values. But if we use exchange, then bx and ax, the data in bx and ax will be swapped. Similarly, xlat is used when we use lookup tables. It locates a byte entry in a table in a memory using the contents of AL register as a table index, then copies the contents of the table entry back into the AL register. So this is the syntax of xlat. So here use a load effective address, and the table name has been given. This is what the lookup table size was mentioned, and that will be translated. That will be translated from using the lookup table, from the lookup table. And this is another data transfer instruction. So in the first we have discussed about the data transfer between registers or an immediate instruction or data from a memory. Next we have discussed the data transfer between a register and a stack. Next we have discussed exchange of instructions. And now coming to this, in and out is a bit different. That is, this 8086, whenever it wants to move or transfer a data to a port, right, to an input port or an output port, then in or out will be used. So here the transfer of data will be between the accumulator or register and the ports. So this is used, in and out instructions are used to transfer data in between the ports, inputs, port and output ports. And these are also data transfer copy instructions, which is load effective address, which we have come across in when we use xlat also. Then load DS data segment register, and it specify register from the memory. The syntaxes was also given. Similarly, load from extra segment register. Then we come across the flag transfer instructions. The data from the flags can also be, so 9 flags are available in 8086, which was being discussed in the architecture of 8086. So you can go and have a look there. So the flags, 9 flags are there. three conditional flags, branch flags, and six normal flags are there, like carry flag, auxiliary carry flag, sign flag, zero flag, overflow flag, and parity flag. So these, when we want to transfer data from these flags, then we'll be using this instruction. So here it is used to load something in a flag, what is there in A, H. This is used to store in a flag. This is a push and, that is stack into the flag, and pop into the flag. So these are the different instructions which we can see basic data transfer instructions. So we have discussed data transfer between registers, between memory and register, between immediate data and register. Then we have discussed about exchange of instructions. We have discussed about push and pop, that is exchange of instructions, transfer of instruction between stack and registers. Then the exchange of instructions, then transfer of instructions between ports and registers. Then we have discussed effective address, loading of effective addresses, then transfer between flag and registers. So flag, when flag has been used, a register is commonly used. And here is for your assessment. What is the purpose of push instruction in 8086 microprocessor? So already I have given you push and pop are related with stack. So it's a clue for you. Second question is, which of the following instruction is used to move data from AX register to BX register in the 8086 microprocessor? Which is used to move data, just moving of data in 8086. So this is for your assessment, and thank you.